In the next example, you're given that a rod of length L slides on coordinate axis. Find the locus of midpoint of the rod. So you have a rod of certain length L. Now this rod is sliding on this coordinate axis. As this rod is sliding on the coordinate axis, what is the locus of the midpoint of this rod? So you can think of this question as something like this. You can think of the question as you have a ladder of length L. Assume that the ladder initially is vertical. Now you have alighted the ladder till its midpoint. Now someone comes and slides the ladder. So what is the path in which you fall down? You're exactly at the midpoint of the ladder. Obviously you won't fall down directly vertically downwards, right? Because you're not jumping from the ladder, you're just standing at the midpoint of the ladder. So as the ladder slides, you take certain path. That is, if the rod is vertical, the midpoint is somewhere here. As the rod is sliding, the midpoint has come here at some point, and as the rod has completely come to rest, the midpoint has gone somewhere here. So the path will be approximately in this, along this curve. So you're asked to find the equation of this curve. So now this is a slightly more involved question, but we start with the same premise. The first step is let PH, K be a point on the locus. So let PH, K be a point on the locus. That means as this rod is sliding at some instant, let us say that the midpoint of the rod is H, K. Now, how do we convert the condition which is given? So the condition is that PH, K is the midpoint of this rod. So how can you create a mathematical condition corresponding to this physical condition? Now we know that P is the midpoint of this ladder. So how can you construct a mathematical equation corresponding to this? So you can think of different ways of writing the mathematical equation. So without any extra numbers, it is very difficult to write the equation corresponding to H, K. So this condition is not a direct condition. Okay, P, H, K is the midpoint, but what equations can I write? So H is equal to something, K is equal to something, I don't know what to write. So in such cases, we create new variables. So we create a new variables. These are nothing but algebraic variables. So let us say that, let us call this point as A, this point as B. And as the ladder moves, these 2 points A and B also move. These points A and B also move. Just imagine the animation. Imagine an animation where this rod is sliding along the coordinate axis. So as the rod is sliding along the coordinate axis, this point and this point obviously changes, right? So let us say that the coordinates of A are A, 0. I don't know what A is, but I know that the y coordinate is 0. And let us assume that the coordinates of B are 0, B. A and B are the new variables. So assume A as A, 0 and B as 0, B. Now, using these variables, write the equations if you can. Now, what is the condition? PH, K is the midpoint of this. So, PH, K is equal to So the midpoint is a plus 0 by 2 and 0 plus b by 2. Now you are able to write some equations. So h is equal to a by 2 and k is equal to b by 2. So you got two equations. Now what is the equation of the locus? Equation of locus is some algebraic condition only in terms of h and k. So you should not have any a and b's. That means you need to eliminate a and b. So your aim is to eliminate a and b. So remember, in deriving the equation of locus, whatever the number of new variables you have introduced, you need to have one extra equation. In this question, you have introduced two new variables, so you need three equations to eliminate two variables. So to eliminate two variables, we need three equations. So you have already two equations with you. So what is the third equation which is present in this question? The third equation which I have not used till now is that the length of the rod is fixed. As the rod is sliding, the length of the rod is not changing. So what is the length of the rod? The length of the rod is root of a square plus b square, right? Root of a minus 0 whole square plus 0 minus b whole square is equal to L. This implies a square plus b square is equal to L square. And what is a? 2h. So a is 2h, b is 2k. So 4h square plus 4k square is equal to L square. Now you got an equation completely in terms of h and k. So remember the difference between variables and constants. Here L is a constant, so you can have L in the equation. But a and b are variables. As this rod is sliding, a and b are changing. So you have to eliminate the variables. Constants need not be eliminated. So the equation of locus is nothing but x square plus y square is equal to L square by 4. So this will be the answer to this question.